Alright, this time I'm looking at building up coherent connections in the OSI 7 layer model. In this case it's layer 4, the transport layer. So the actual transportation layer is responsible for the segmentation of data, i.e. breaking up into bits, sending and acquiring acknowledgements, and the potentiality for multiplexing, and I'll cover each of those in a moment. So segmentation, rebuilding it or reassembly is basically you break up a large message, this be a text file or more likely video or images, possibly audio, into smaller bits so it can be transmitted from A to B. Video files tend to go more into the streaming side of things, which is a slightly different standard, but I'm not covering it here. The acknowledgement, the message has arrived appropriately, uncorrupted, ready to be used. Error control is part of that, basically checking it to make sure that the entire block of data is self-contained, is appropriately delivered, and to request retransmission of the missing parts if it doesn't arrive completely. Flow control also can control the arrival of the messages at the destination or the travel through the network as well, so that the destination node doesn't get overwhelmed with too much data at one time. Now, the other side of this thing is multiplexing. Now, multiplexing is basically dumping multiple signals onto one communication channel. So if you think of the undersea cables running between, say, Australia and America, or Australia, Asia, whatever, here we're able to basically blend together multiple signals and then extract them at the other end to basically, instead of having a requirement of millions of cables running between here and there, we're able to dump on multiple signals onto less communication mediums. The way this is done, and I'm only covering 3 of the techniques here, is space division multiplexing, which is basically, as the example gives there, splitting up headphones into multiple lines, so that as it comes out of the socket in your mobile phone or stereo system, it's split into left and right audio, and that way it's basically space division, or divided in space. Frequency division, it has to do with the actual frequency of the technology of the signal. So if you think of AM and FM radios or a TV, basically they share one electromagnetic spectrum, and what they've done is they've placed the signal on certain frequencies within that spectrum, and when you change the channel you're able to pull out that frequency and listen to it or watch it. A variation of that is wave division multiplexing, which is used for optical fiber. So in this case, think of different colored lights blended together, and when you extract at the other end, you extract that particular color. So red, green, blue is a simple example, and you split it off at the other end. Finally, there is time division multiplexing, which is really looking at different timings in terms of the transmission of the data. And I gave an example before in one of the earlier videos about CSMA, or carrier signal multi-access, I think that's the one, or slotted aloha, where basically you transmit within certain blocks and that sort of stuff. Now, at this point, I am jumping a little sideways into domain name services, because if we look at the transport layer, it's responsible for the transportation of a signal from A to B, and that's usually through the IP system. And what we do is we get a domain name and convert it to an IP address, and globally there is a hierarchy of domain name servers that, when given a domain name, respond with an IP address. And if you look here as the example, we have the root server for the entire internet, and then it's split into particular domain styles, and then within that, say the .ie is then split into edus, and then other areas within that, and then finally the local server. And then within that you may actually get folders and files. So Wikipedia is an example of that sort of stuff, and there's actually what they call the root domain for the internet, and I think there's about 13 servers across the entire world that actually handle the root of the domain name services. So originally in these top level domains you had your .coms, your .orgs, etc, and they're all on the slide there. That's been subsequently broken into chunks, because originally it was just built for America, but as the internet spread across the world, We then added country codes. In more recent times, we've added generic words, geographical regions, and brands. And there's a couple of reserved ones, which are especially for examples or an invalid address, the local host for 127.0.0.1, and so on and so forth. So these root name servers are located all over the world, and you'll notice them mainly clustered in America, with some in Europe as well. And basically, if you could take out all of these servers, the internet would stop. Well, not exactly. Because these name servers maintain a complete DNS list of all the domain names and all the IP addresses that go with them, but your local ISP will actually have a copy of that. So what happens is, usually when you request something, is it'll go to your local ISP, and if they have it, they'll give it to you straight away. If they don't, they'll go to the regional or country-based DNS service, which will have all the country-based ones. And then if it's not there, it'll go to one of those root ones around the world. So a lot of ISPs will have the common addresses, IP addresses, and names for local services and for the very common places on the internet, such as Wikipedia or Google, etc., etc. And so this is sort of how this service works in that sort of sense. And so once you've got the IP address, it'll bounce down that system so that you can actually then travel to the particular internet address. And this happens every time you type in a URL, or unique universal resource locator. And you can also set up black hole DNS servers, which are basically respond with non-existent addresses, so that when you request it, it doesn't actually go anywhere. And that's it for this one. Thank you for your time.